Every developer using an AI-powered IDE has hit the same wall. You're mid-refactor, deep in a service layer, and you need to ask a second question, but your agent is busy, so you wait. Or you cancel, losing context. Or you open a separate window and start from scratch, re-explaining everything. For toy projects, this is a minor annoyance. For production code bases spanning dozens of services, it's a fundamental constraint. Cursor 3.11 aims to break it. Released in mid-2025, Cursor version 3.11 introduced 3 interconnected features. Side chats allow developers to run multiple agent conversations simultaneously within a single workspace. Agent transcript search makes every past interaction, every design decision, every rejected approach retrievable through keyword and semantic search. And advanced agent controls let developers scope each agent's file access, tool permissions, and context window with precision. Individually, these are quality-of-life improvements. Together, they represent something more architectural: the IDE as a stateful, multi-threaded AI collaboration environment. Here's what side chats look like in practice. Imagine you're migrating a PostgreSQL schema. In one thread, an agent is generating the migration scripts, rewriting affected queries, updating the ORM layer. That work takes time and iteration. Meanwhile, in a parallel thread, you're asking a second agent to explore whether a Redis caching layer could eliminate the need for 3 of those queries entirely. You're comparing 2 futures simultaneously, not sequentially. The threads share the same workspace but maintain independent context. One agent doesn't see what the other is doing unless you explicitly bridge them. This is the key design choice. Transcript search addresses a problem most teams don't realize they have until it's too late. AI-assisted decisions vanish. You asked an agent 3 weeks ago why it chose one API pattern over another. It gave a detailed explanation. That conversation is gone, buried in chat history, or lost entirely. Cursor 3.11 indexes every agent interaction. Search for rate limiting and surface every conversation where that concept was discussed. The trade-offs weighed, the alternatives discarded, the reasoning preserved. This is version control for thought, not just what code changed, but why it changed. For teams onboarding new developers or revisiting past architectural choices, this is the feature that compounds in value over months. Advanced agent controls solve the context bleed problem. In most AI coding tools, the agent sees everything, or at least tries to. It pulls in files you didn't intend, makes assumptions based on unrelated code, and occasionally modifies things outside its mandate. Cursor's new controls let developers restrict an agent to specific directories, disable write access to production configurations, or limit tool usage to read-only operations. You can run an experimental agent that explores freely in a sandboxed branch, while a conservative agent handles only the migration you've already planned. Tight scoping isn't just about safety, it's about signal-to-noise ratio. A focused agent produces better results because it's not drowning in irrelevant context. To understand why this matters, consider how most AI-assisted IDEs work today. GitHub Copilot, standard ChatGPT integrations, even earlier Cursor versions, they operate on a Solo-Agent model. One conversation, one context window. When the session ends, the reasoning disappears. This mirrors how we first used search engines. One query, one result page, start over. Multi-threaded agents are to solo-agent IDEs what tabbed browsing was to single-window navigation. The underlying capability existed. The interface just hadn't caught up to actual workflows. The deeper unlock is statefulness combined with auditability. In complex multi-service code bases, the kind that power fintech platforms, healthcare systems, logistics networks, decisions ripple across boundaries. Changing an authentication flow affects the API gateway, the user service, the notification pipeline. A stateful agent that remembers its prior reasoning across sessions can maintain coherence across these boundaries. An auditable agent, whose transcripts are searchable, means that 6 months from now, when a bug surfaces in the notification service, you can trace the reasoning chain back to the auth refactor that caused it. This isn't theoretical. It's the difference between AI as autocomplete and AI as a genuine engineering partner with institutional memory. None of this is without risk. Multiple concurrent agents increase the surface area for conflicting changes. Searchable transcripts can create false confidence. The reasoning was preserved, but was the reasoning sound? And scoping controls are only as good as the developer configuring them. There's also the dependency question. As agent transcripts become institutional memory, organizations risk coupling their engineering knowledge to a proprietary tool's data format. Portability and export capabilities will matter enormously as these systems mature. Cursor 3.11 is not the destination. It's the proof of concept. The trajectory points toward agents that communicate with each other. One thread flagging a dependency conflict to another, toward persistent memory that spans projects, not just sessions, toward team-shared transcript libraries where collective AI-assisted reasoning becomes a first-class engineering artifact. The competitive landscape is responding. Windsurf, Copilot Workspace, and autonomous agents like Devin are all converging on similar ideas. The question isn't whether multi-threaded, stateful AI development environments will become standard. It's who builds the version that engineers actually trust with production code. The IDE war just became an infrastructure war, and the infrastructure is memory.